Alright, if you're watching, welcome. It's been a while since I did one of these flights around the world here in the ToLiSS. I've been pretty busy with work and travel, so I thought I would do a quick flight down to London City. I've already got it planned out through SimBrief and pretty much got everything ready. I just got to set up the airplane and try to get that done pretty quickly. Get underway. I'm not going to do too much talking here. A little bit limited on time, but also it's going to be offline because I just don't have the time to do it on VATSIM today. So I'll talk a little bit about the planning once we get everything set up here, and go over the routing and fuel planning. I also did some takeoff performance using the Airbus FlySmart application that I use for work. We don't have a database for every airport in the world, so what I basically did is took an airport that was roughly at the same elevation and just modified the runway, shortened it to the length of the runway here at EGPD, Aberdeen, and then calculate the performance. The only issue is the obstacles are not going to be in the right place. So that that again is the only difference. But the only limitation today, well, I can't even really say that because it's based off of another airport. So if there's any kind of obstacle or terrain limitations, that won't be accurate. But my curiosity is why I did this. I want to see how accurate the ToLiSS, which I don't expect it to be too accurate. Again, it's just designed to get some speeds in there and get you going here. So let me get things here to match, and then we'll get underway. Alright. I'm just going to load it up here and use the flight release that I have to get things set. I just need a 0 fuel weight here to match, and then I can distribute the passengers as necessary. 48. And let's just do it this way. I'll slide this over. Alright. Okay, 0 fuel weights, 48. Even. Alright, that works. Move them around, apply those settings, and I am going to take, I've rounded the fuel up to 7. Put that on, ground services, I've got external power. None of those. Faults none. Tillers assigned. Okay, I think we're good. Alright, let me go ahead and get this thing aligning so I can at least get that started. We got external power on. Okay, got the current cycle. I think cross my fingers here. Whoops. I think I have to do it this way. It's been a while since I flew this. EGLC, let's do it. Nice. Alright. And let's go ahead and get this going here. Okay, so just real quick on the flight release. Again, really I'm operating the aircraft under Part 91. So this really wouldn't even be required, but some form of a flight plan would be required. I'm just going to do this as a release real quick. So it's a third flight plan I produced for Flight 1990 on the 20th of April. It's Aberdeen to London City, A319, November 1990 Bravo. It was released at 1701 Zulu on 20 April of 18. Call sign and tail number, aircraft and engines, scheduled departure, scheduled push, takeoff, landing, arrival. We're cruising at Mach 7.8, and we got an average wind component of -24. Estimating a takeoff weight of 54.36 and a landing weight of 51.3, and up to 380. The trip fuel is 3023 with contingency, alternate, and reserves. It's a min of 63.28. That's 2 hours and 53 minutes. Taxi at 200 gives us 65.28, and I threw an additional 500 in there for 7 tons. Okay, the alternate is Paris Charles de Gaulle. They got 39,000 in here. I didn't mess with it. We'll definitely not go that high for just 243 nautical miles, but we could. And there's the flight plan that I'll be putting in as well. No MELs or CDLs. Here's our current flight plan. Findo, Upper Lima 613, TLA, Upper Number 864, DCS, Upper Lima 612, Han, Jack 1, Hotel, and runway 27. Here's the payload. Nothing's going to change, so we're going to have 54.4 on takeoff, 51.3. I did calculate some preliminary performance. Let's see what ToLiSS gives. Now, again, this is on a tail number that doesn't exactly match, you know, the empty weight and so forth, so it could be a little off, but it's going to give us a little bit of play here with V1. I'm going to leave it at 112, 115, 123, and a green dot should show up of 195. Max takeoff weight for this runway is 71.3, and this is 112 is going to give us a stop margin of 794 meters, and 115 would give us a stop margin of 695. So we're just going to go with 112 since it's a little bit shorter of a runway than a little bit extra margin there. And I just highlighted a few things here. Let's see. I went ahead and highlighted the top of climb on the flight plan, 380. I've also got noted the outside air temperature at our top of climb, and the lowest tropopause point is going to be 380, and the greatest shear we're going to have is 3, so it should be a pretty smooth flight. At the top of climb, we're going to have about 5 tons of fuel on board, and then we'll monitor from that point. Asterisk is the exit point. That's where we'll be going to London FIR. And the highest grid moor in the area is at Dean Cross at 5,300, and also right there at London City. Well, that may actually be the highest point. Doesn't really say. I'm not sure on this flight plan. It looks like it would be 5,300 in London City as well. Let's see, what else? Get my hand back here. That is pretty much it. We're showing arriving at 3.3. Diversion is 2.8, planned diversion. And if you're not familiar with what that is, it's like a bingo. And it's the total of the reserves and the fuel at the alternate. So I just rounded up the alternate fuel to 1.8, and I rounded up the reserves to 1. So if we show an arrival fuel at London City of less than 2.8, then we're minimum fuel. So that's basically why I put that down there. That's a number we pay attention to as well. I'm not sure if the ToLiSS FMC will let us enter that, but we'll give it a shot. So that's basically the release. I'm using real world weather. Should be pretty nice. Departure weather is 250 at 14, varying between 220 and 280. We're going to take off 3-4. Clear skies, temperature 16, QNH 1020. And then for London City, variable again, 230 between 230 and 320, out of the west 5, 25 on the temperature 1022, and you can see later on it's Cabo K, and then becoming 02010, and of course the Paris weather is nice as well. So that's not going to be considerations. I'm not going to mess with NOTAMs. I think down the road and in the future I'm going to go through the NOTAMs and then you know, consider those NOTAMs as active for the flight and then operate accordingly. But like I said, I don't have much time today. Just want to kind of get this moving again. You kind of see the winds here for the flight plan at the different levels. Southwesterly at 50, pretty much along the entire route. At 30, 34, pretty much the same, and then up at 39 as well. So yeah, and then here's the trop. You can see the tropopause is in these areas right here. So we're going to be operating under the tropopause for this flight. And that's pretty much it for the release. All right, for the airports, we're out of Aberdeen, and we are parked. Where are we parked? Well, let's see. We're presently facing east. I think we're tucked in right here. Yeah. So what we're going to do is push. We'll taxi out down this way here. Let's see, 1 and 9's Alpha apron. And boy, it might just be easier to do a back taxi. But actually, we're going to go out here. We're going to taxi down this taxiway here. Back taxi runway 32, and then back taxi 34, and do a 180, and we'll set up down there. So that's the taxi plan. And they do have noise abatement for departures. It says minimum noise routings are depicted on the Aberdeen departure. We'll see if that can be pulled up in the FMS, MCDU I should say, and if not, then we won't worry about it. There's radar minimums, but again, we're not under radar control, so you can't really use those. Here's the departures they're talking about. And we'll be off of runway 34. Now we're going to be going to Perth in the flight plan, so it says climb to 1220. So depart, we're going to climb to 1220, then a left turn, intercept the radial 220 off of ADN via Glesk to Perth. And that's the low noise departure. Use 1220 before you can start making that turn. So that's the departure procedure we're going to use. And if we can't load it in the MCDU, we'll program it into the MCDU. And if we can't do that, then we'll fly green dots, green needles, sorry. And so that's the taxi. And if we come over here and look at our routing, you can see this is going to have us picking up the 220, so we'll just track that. Once we get on there, we'll tack that up to Perth, and then Findo. And then we're going to take it on down to the south here, over Dean Cross, and down to the southeast on Upper Lima 612 to Coventry, or excuse me, Honolulu. Then this is the arrival, going into London City. Sorry, it's a Jacko 1 hotel. It's an RNAV. And you can see from this point right here, we'll flow down and then pick it up here at Jacko and get right onto the approach, which is going to be the ILS runway 27. And that's Mins, there we go, and we'll set up for that here. So that's all the ways down the way there. So, but anyway, just kind of give you an idea what the flight plan is. I've also got a link there. Well, I'm not sure if it's on Twitter, but if you want the link, it's on my YouTube page. Maybe I should put some links out there for that as well each time. But yeah, that's the plan, and let's get after it. Okay, so I'm going to go ahead and set the aircraft up. I'll just do that, and then we'll get started here. Alright, let's get the weather here and we can plug in some of this stuff. Okay, altimeter is 1020. Might as well do this while I'm thinking about it. Alright, date is good. Okay. Is good. Can't do the recall. Don't know why that's not working. Alright, let's make sure stuff works here. Okay. Okay, that works. Is that it's been so long since I flew this, I got to make sure autopilot. Okay, so we won't use that. Park and brake works. Let's set some sort of bogus code here. This transponder has got to go. It's awful. Alright. Alright, let's go set up the first officer's side real quick here. Constraint. Gonna leave that there. Alright, back to the box now. Alright, I'll hoping I could detach this window, but I'm not going to be able to, so I think probably it's more important to look at the box than anything, so progress, flight plan, okay, EGPD fin no. So what I'm going to do is I'm going to change this a little bit because of that noise abatement departure. If you recall, I'll bring this up here. The noise abatement departure here is asking for to fly. Let's see, climb to 1220, then turn left and intercept the 220 off of Aberdeen to Glaston, Perth. So what we'll do is we'll modify this slightly. We'll put in, well, first of all, let's see what it'll do here. Departure 34. And this is going to be the Perth. Insert. Nice. Alright. Simple enough. And then if I look at my flight plan here, after Perth, Findo. Yeah, so we'll just bring it right on there. And let's take a look at it. In the plan view, constraint. So there's the turn. It's got the 1220 in there. It's got our left turn. Perth, fin no, and off we go. And we'll put in the arrival of runway 27 ILS via, let's see, we don't really have to do too much of this right now. And is there a via out here? Now let's take a look and see what it is. Let's erase that. I really hate that I can't see. There we go. Jacko. So ILS 27, no star. Via don't really see. Let's take a look. There's not really nothing on the approach either, so this is probably another arrival. So let's look what the arrival says here. Jacko 1, it says do not proceed past Jacko without ATC clearance. So let's go ahead and put something in here and see what it looks like. Yeah. So we don't want to do that. We don't want those vias in there. 27 via, no via, insert, and then we should be good to go. So Jacko, and since no ATC, we'll go straight there. Alright, that's the primary flight plan. Good, good, good. So let's put in the rest here. We'll get out of here. So alternate is LFPG. Cost index is let's put 25, 380 at minus 54. Alright, there's something else I need to do here while I'm in here. Ground service configuration 1 plus F. Oh, look at the speeds he's got in here. Totally different from So I got a takeoff weight of block is 48, fuel is 55, and we're doing toga. This is 1 + F. So the speeds I have selected are for toga, so they're going to be a little bit different. So we won't be able to do that. But let me write these down real quick. Tools, typewriter. Performance is here. It's going to be TOCG is 34.0, trim 1.0 down. Save that and get out of that. Okay. I think that's everything. Alright. Flight plan is in there. Now we need to build this flight plan to the alternate, which is gonna be departure runway 27. That's 5. Insert lid. Can't really see this, unfortunately, but there's nothing I can do about it. It's LYD. Oops. Yeah, what's off a lid? Sorry. There's something odd about this. It's the older software version. It's a little bit different than what we're used to. So lid, upper mic 891 or 189, and then upper mic 605. See, I should be able to put that in right there, but it doesn't let me. So I got to build every fix, which is a little bit extra time. See, this is what it normally looks like, and with no 2-fix, you could just put in the next airway, and it would put in the 2-fix automatically. Upper mic 605, and that'll take us to Hardy. And mic 605, take us to XI. And then upper mic 605. And that takes us out to B-backs. And then for the arrival, let's just pick a runway. Let's go westerly. VOR 27 left via the Biba 8 Papa. Okay, so if we now look at the alternate flight plan, it's a complete and utter mess. There's the departure all the way down to 27 left. And let me make sure, oops, that's the wrong one. I'm not too concerned about this. It just VOR 8 and VOR 27 left. I think it's the 1 Papa. 8 Papa. And then there's these transitions, but I'm just not going to put anything in here. I don't plan on going there, and if I do, I'll worry about it once we get there, but I'm just going to put it in like this. It's good enough for now. Let's see. Noise abatement procedure is going to be the ADN. And we'll track the 220 as a backup. And then we can also put 1143. Also 220. Alright, that'll take us out to Gillespie. That's good. Alright, I think that's taken care of. Oh, goodness. EGPD. Alright, performance. We are going to do a TOGA, and I'm going to use the numbers that I calculated, which are for TOGA, and I used my real-world FlySmart app off of the iPad from Airbus. And I just basically, like I said, I modified this runway on my iPad. It's basically the same airport elevation. The only thing that won't work are obstacles. So these speeds are based on the obstacles from the airport that I did it on there in my application, but it won't work here. So it's just going to have to be close enough. But anyhow, we're going to go with, decided to go with, whoops, it's going to disappear. I'm going to go with 115, 115, 123, and green dot of 195. That may not match up, but we'll see. Because again, the weights on the application are a little bit different here than here in ToLiSS. Pretty close, 196. And 123. I bet if I made my airplane here the same exact weight as the one in the iPad, it would be right on the money as far as basic empty weight. And it's going to be a TOGA takeoff, so flaps 1/down 1.0. And I got that from, of course, the ToLiSS app here. So when you select, but he doesn't give you the option to select TOGA. He doesn't give you TOGA speeds, which should be in there. So I'm not going to use the flex. We're going to use the TOGA. So it's going to be TOGA and airport elevation. I guess I could get you over here to the right screen. There we go. We'll go over this when I do the briefing anyhow. So airport elevation is 215, so we're going to go 1200 twice. And we'll go 1700 for engine out. Fuel prediction, okay, that's not going to be there until the secondary doesn't work. So we can go ahead and initialize this, and what I'm going to do is I'm going to put in the actual zero fuel weight of 48. Bring that over there. So I'll put in the CG and the zero fuel weight. The CG was taken again off at ToLiSS, so it's going to be 34.0/48. 34.0/48. We got a block of 7, and that's going to give us a takeoff weight of around 54.9. I got 54.8, and landing weight of 51.8, and roughly 52, with an extra 1.5. Route reserves 5%, alternates 42 minutes, 1.5 tons. Interesting. Let's see if it's given a fuel calculation on here. Yeah. So alternates 1.5 and planned is 1.7. So very close. All right. We've got the takeoff. We got the init. Now the fuel prediction should show 4.1 landing in London City and 2.5 in Paris. Good to go. Alright, let's go ahead and finish up, and we'll get going here. Okay, oxygen check. Alright, let's go ahead and get the AP going. Alright, while the APU is starting, I will go ahead and brief this. I'll try to do the best I can, bouncing back and forth between screens. Makes this a little bit of a pain in the butt. Okay. So we're in November 1990 Bravo, parked here. Right, display, boom. Parked over here at this location, tucked right in the corner here. And no pushback or tow. We're going to do an auto start right here in a position, and then we'll taxi out with a back taxi of runway 32. Actually, let's take it down here, and then taxi down this route, all the way down here to 34. Yeah, that's the taxi plan, anyhow. No NOTAMs for the airport, MELs, CDLs, nothing. So the aircraft status is good. Current weather is cavalcade, dry runway, radar on, anti-ice off, and packs on for departure. Looking at the box, let's come back. We got A319-112 aircraft, CFM56-5B6 engines, and we're good through, well, it doesn't give us a date, but it this is an older version, I guess. Anyway, we have the current cycle. We're Aberdeen to London City with an alternate of Paris. Flight number 1990, cost index 25 up to 38,000. And normally you put the tropopause there, but I'm not sure in this version how they've got it working. Zero fuel weight is, and this is where you want to kind of double check your numbers. Zero fuel weight is 34. And, excuse me, the CG is 34 for zero fuel weight, but it doesn't show that. Actually, that's the takeoff CG. Hang on a second, I boo-booed there. That's what I don't like about this. What can I do? The zero fuel weight CG is 33.1. So, close that. 33.1 by 48.0. That 34 is the takeoff CG. That's what you're going to see here. Well, this version doesn't show it, but that's what you would see on the fuel prediction page for your takeoff CG. Oh yeah, there it is. 34 right up here. And a gross weight of 55. Let's see, where was I? Okay. With a block of 7 tons on the fuel, and that is, whoops, wrong one, on board and balanced. And that's going to give us a takeoff weight of 54.9. We've got 54.8 and a landing weight of 51.3, extra 1.5 or 1 hour of fuel. The flight plan, the clearance is nothing. We're just going to give ourselves our own clearance. We're going to be doing a, let's see if I can bring this over here without causing too much of a problem. After the taxi out, we're going to be doing this noise abatement procedure, which is just basically what the noise abatement says is minimum noise readings are depicted on the Aberdeen chart and are compatible with ATC requirements. So all we're basically going to do is just follow the chart. So what we're going to do here, since we're going to PTH, it's going to be climb to 1220, then a left turn and intercept the radial 220. That's over here. and track that out to Glesk, then Perth, I think is what it's called, Perth. And that'll comply with the noise abatement. So no turn until 220, so we'll nav it up right on departure, and then we'll track it outbound. So that's departure procedure, and then the flight plan route is as depicted all the way up to 38. And for the descent, I'm not going to mess with anything right now, but I do have the arrival in there for the planned arrival for London City and the runway. Again, we'll brief that once we get to the top of descent. And the alternate flight plan has taken us to Paris, and that's in there as well. The rad nav is just backed up for the departure procedure in case we lose the FMC, and that's a radial 220, and then we can use the DME out to Glesk and Perth. GPS is primary, and we got high accuracy. Performance is set per our calculation, 115, 115, 123, green dots 196, 195, flaps 1 down, and it's toga. Engine out, or thrust reduction in Excel will be 1000 AGL, engine out is 1700 AGL. Fuel prediction shows 4.1 at London City, and Charles de Gaulle is 2.5. And we have a planned diversion fuel. I wrote it somewhere here. Where? Planned diversion at 2.8, and so we'll need to have 2.8 at London City. And that's where we get the extra fuel at anyway. So we're showing, estimating, well, planned 3.3, but we'll see what it actually is when we get there. Secondary, sadly enough, we don't have the option for a secondary flight plan, so I don't brief that. For the emergency procedures, any abnormalities prior to V1, I'll call stop or go. If I stop the aircraft, I'll stop the aircraft on the runway, set the brake, and then run the ECAM actions. If I have to evacuate, I'll run the evacuation checklist off of the back of the QRH. If I call go, no actions prior to 400 feet except for silencing the alert and landing gear up. I'll get the autopilot on, and then I'll run the ECAM actions. Looking at the departure here in terrain, there's no engine out procedure, but I do want to look at these radar mins. Okay. So that's 10. So what we're going to want to do here then for an engine out procedure is if we're not cleaned up, see we got these altitudes over here. The initial altitude, I'm just kind of making up a procedure on my own here. Doesn't give us initial altitude, but what I'm going to do is I'm going to set it to 5,000. And then what we'll do is we'll track straight ahead, and then at 10 miles, if we're not cleaned up, we'll make a right turn, and we'll proceed back to the VOR, and we'll enter a just a direct entry hole. I don't really see any. Let me see if there's some sort of a. Let's say we're landing on 3 on 16. Let's see what would be there. Okay, so we'll enter this hold over Aberdeen, which is inbound 160 and left turn. So that's if we lose an engine, which we're not going to. I don't have any of that stuff set up to fail, but you know, never say never. So that's the emergency return plan. We'll be underweight, and we'll shoot the. Looks like we're going to be shooting the 3-4 in. So this is the hold that we'll do. We'll proceed to Aberdeen, then we'll track outbound on the localizer, and we'll hold here while we run the checklists and come back to land underweight in Aberdeen. So that's the emergency plan. And looking at the box again, I think we're all set up, so that should take care of all the briefings. Let's get the ground power disconnected here. Lead. And I think I gotta go up here as well. Ground services, external power's off. Alright, so we'll do a before start checklist and then get underway here. It's taking long enough. Alright, the cockpit prep is completed. The gear pins and covers are removed. Signs are on and auto. ADIRS is nav. Fuel quantity. Let's see, this is easy enough. 7,000 on board. Takeoff data is set, and I'll put flight plan on his side. And barrel ref is 1020. And that's down to the line. I don't really think there's anything else. I'm going to take a quick look outside. For some reason, and I don't know why, I just have no idea, this airplane will stick. It just will not move, and I just don't know why. It's going to take me probably 75% power to get this thing rolling, and I've asked other people, but I have no idea why it won't, why it sticks to the ground like that. So it's the only airplane that does it. So there's something either I'm doing wrong, which is not blatantly obvious, or there's something wrong with it on my end. I don't know, but so maybe I can exercise the brakes or something. We'll see what it does. Okay, let's go ahead and do our flow and get everything set up here. Get ready to taxi. Okay. The steering pin is not in there. That's correct. Door is locked. Door is closed. And here we go. Below the line, doors and windows are closed. Beacon is on. Thrust levers are idle. And the parking brake is on. And that is for start complete. Let's go ahead and fire it up. Get these somewhat situated. Not required, but there's the bus transfer, so we got 2 electrical networks. And let's start number 1. Okay. Start a control valve. We got into rotation. Looking for ignition down here. Ignition, fuel flow. Within about 10 seconds we should have light off. Whoa, super light off. Alright, yeah, let's alright, 246.5. Good pressures, temps, and vibration. I missed my first officer. I have to do everything now. That's wrong. Why that's there. Okay, the trim is 1 down. Let's see. We said 34, so let's just put it to 34. Now let's look up at the flight control page. 0.9 down. There we go. All right, after start checklist. Anti-ice off. Cam status is checked. Pitch trim is 34% set. Rudder trim is 0, and the after start checklist is complete. We're just going to go ahead and make the cabin ready. Let's see, how the hell do I do that? I think it's that right there. Yes, cabin's ready. Alright, we're kind of a tight little spot here, so it's unfortunate that I have to give this thing like takeoff power, but it's all I can do. I don't know what else to do here. So let's release those brakes. Let's exercise the brakes, and hopefully it will okay. I'll take it. And sorry about the track IR. I'm going to use it initially here to get out of here. Jesus. I tell you what, I think I'm going to turn it off. Hold on, it's just disorienting me. Something here. Sorry. There we go. Alright, I think that'll work. We'll just leave it off. The other thing that's a little tricky here is this tiller is a little off. It's like in the airplane, when I move the tiller, I mean that wheel turns to the point where I've got the tiller pointed. Here, because this is, you know, kind of a, well, it's a joystick setup. Whenever I move the tiller to the right, if I just move it immediately, it takes a few seconds for the nose wheel to actually start turning to that position. So that's a little bit of a pain in the butt. Alright, missed my taxi light here. Now here's our taxi route we're going to take. This is annoying. I hate this limited field of view. Okay. Scoot back in my seat so I got a little bit better view. That's looked like I'm taxiing on my kitchen floor. I'm just going to do the flight control checks and everything down. Maybe this is one of those airports I need to modify. Alright, let's do a quick flight control check. Full up, full down, neutral, full left, full right, neutral. That's what I need to do. Crap. Oh, wait a minute, I know what it is. It's this button. Full left, full right, and neutral. First officer would do his controls, and then we'll go, where is it? Auto brake max. I'm going to have to release the park and brake here so I can do the takeoff config, and then we're set. Okay, confirmation briefing. Well, I missed these, damn it. Let's get these. I said 5. I missed it. So it's going to be climb nav 5,000, and it'll just nav up, and as we said, it will take that departure and it will fly until 12:20 and intercept, and off we go. And in fact, let's just go ahead and set it up to a higher altitude. Right on up. No sense in, we don't have ATC, so there's no reason to make any more work than we have to. Okay, nav 20. Get all this stuff set up, so it is looking good. I don't think I necessarily need that one. Let's just put that right there. Alright, I can do it before takeoff. Flight controls are checked, flight instruments are checked. And briefing is confirmed. Flap setting. Configuration 1, 1. Check there. V1, VR, V2, flex temperature 115, 115, 123. Which, look down here, 115, 123. And toga, which is over here. ATC, let's go ahead and set that now. It's in auto, that's correct. ECAM memo is takeoff with no blue. Takeoff is complete. Well, down to the line. And let's go ahead and do all of this now so I don't do it on the roll. And it's hard to taxi and do this at the same time. Cabin crew be seated for departure. I can't set the TCAS in this version. Engine mode select is normal and the packs are on. Alright, below the line, takeoff runway is 34, confirmed. Cabin crew advised, TCAS is TARA. Engine mode select is normal, and the packs are on if I haven't done that already. Okay, good. Alright, here we go. I don't know what this is doing. I have no idea what this airplane's doing. What the hell is this thing doing? Not sure if this is Xplane or what, but it just kind of started to slide. Ugh. As far as I can tell. honestly. I don't think we need these that big. Okay, good enough. Okay, toga for departure. All right, last thing to do is brake fan off. Okay, here we go. Take off. That is a quick spooling up engine. Stable. Okay, here we go. Manual toga, SRS, runway, auto thrust blue. Check, thrust is set. It's 100 knots, checked. V1, rotate. Positive climb, gear up. AP1. Thrust climb, climb, auto thrust white. There's 1220, making the turn. S speed, positive airspeed trend. Flaps 0. And flaps are 0. After takeoff, climb checklist, landing gears up, flaps are retracted, packs are on. After takeoff. Down to the line. Got a trees mod in here, or I guess it's a plug-in. No, it's not a plug-in. Scenery. It's really makes the trees a lot fuller, and then I also got this mesh going on as well. A cloud in the sky, at least not close by anyway. Transition altitude is 6. Let's see. 2 fingers is pull, I believe. Yeah, all we can do is push anyway. Standards. Alright, standards cross check, pass in 7-8 now. Passing 8-1, 8-3 now. That's checked. Barrel ref, standards set after takeoff, climb is complete. Release 10,000.
Cruise is 38, optimum is 39, max is 39. I have to take off, or 10,000 checks complete. Now it's just a bit of a haul up here. Let's take a look and see what we got. Top of descent will be 15:53. Time now 14:50. So about 40. I'll be doing the approach brief, and maybe when we get up to cruise, we'll do a little talk about one of the systems. Just have to see what kind of time I have here, but. Right now we're just going to cruise down to London City. It's a somewhat short runway down there. It's let's see. Is this thing tracking me or not? Let's see. I've been having problems with getting it to track. I haven't installed something right. Yeah, there it goes. So it's showing the correct position now. For London City, it's the Jacko 1 Hotel, and then it should be pretty scenic here. Come right up the inlet here and into the airport. Oops, that's not what I want. I want the dash. Well, it doesn't show the right one. That's briefing. Here we go. That is still the debriefing. This is the one we want. So yeah, there's water on all sides of the airport. Well, you can't really see it here, but I guess that's what it's depicting right there. So we'll come in, land on 27, exit at the end, and just go right on down to the GA aprons, the plan. Let's see, the star. I guess we can let them up. And take a look at the temperature. A little bit cool. That's okay. All right, so yeah, Perth out here by my geography's not very good over here in England. And it seems kind of like going out of the way, but if you look, a lot of these routes are northbound, a lot of them are southbound. Well, some of them are south, most of them are north, and then there's some bi-directional. But when I planned this on SimBrief, it actually checks to see if you're entering the route at the correct point and exiting the route. You know, entering the route appropriately, and you've selected the appropriate routing based on direction of flight. And also, if you look, I think if you look in at the NOTAMs, there's even times when you can use certain airways. So you have to look all that stuff up. But SimBrief will do that for you. And the flight plans that everybody were filing in there, it kept showing that it was not a valid entry point to this airway right here. This UP 600. So I made the
the way I built the flight plan, I made the correct entry and then filled in the rest of the route, and lo and behold, it was happy. So this is kind of why we're going out in this direction. And I think also it's designed maybe to take you out around this, probably this, is this a military airway, this is Lake and Heath. Yeah, there's a bunch of air bases out there, so, and with the north directional traffic over here, you're just kind of stuck, I guess, over here on the side. I've never been to the UK flying. I've just, all my flights been in the United States, Canada, now over in the Middle East, so let's see. Alright, so yeah, once we get down here, we'll be on the arrival. This software didn't like the way I entered the arrival, so from this point on, which would normally be the dashed point, I just entered it fix by fix. So this is the arrival that we're going to come in and land in London City. Basically what I'm doing for this around the world flight is I just do searches. I have no idea whatsoever. Sorry to change the subject, but I have no idea why this is building in crossing restrictions within the en route structure that are not there. So that means I have to go and clear every one of these out. That, or at least the lower one, anyway. And maybe when we get over here on the arrival, it'll be a different story. But I don't need any of these crossing restrictions in the beginning. It's a bit annoying. And I'm not sure if this is just the way it's accepting the AIRAC cycle when it brings it in, or what, but I don't know. To be honest with you, it's that stuff wouldn't be there.
Let's see. I am going to try and get my QRH up on the screen here, and I'll show you a couple things here while we're at cruise. Give me just a second here.
Alright, I am just waiting on these two files to upload to my Dropbox, and then I'll show you a couple things here with the airplane that's probably not practiced for the guys that fly it online. Alright, one more minute and I should have the document ready. Let's see if it's now on the... Okay, let's see. Alright, here we go. Alright, let's see. Let's pick Yankee Foxtrot since it's the 319. Let's see, how can I do this? Let me find what I'm looking for first. Okay, so what I have here is the QRH for the A319. And what I have pulled up is a fuel leak procedure. So every hour you're supposed to check and see what your fuel is. That's why we do the, see what your timing and your fuel on board is to keep track of fuel burns, check for leaks, stuff like that. So if you suspect a leak, then you would run this checklist out of the QRH. If you suspect it's from the engine or pylon, confirmed by excessive fuel flow or a visual leak, you would perform this part. If it's not confirmed from the pylon, you would perform this. And then it says if one inner tank depletes faster than the other by at least 300 kilograms in less than 30 minutes. So you'd want to note the fuel and note the time. What's the airplane doing here? Uh-oh. Maybe not the best thing to do over there. Let me move this over here and just change the viewport before we screw something up. Okay. So too late, I think. There we go. So over here we have our flight plan, and then of course, like I said, we check at each of these points. For example, we're getting ready to cross DCS, and it should be 5.1. And if you look, we got 5.1, so it'll be just a little bit less. But then what we do is we check that, bounce it off of the flight plan, and then as we go down through here and we are checking our fuel, and we notice a substantial difference between the flight plan and the actual fuel readings in the aircraft, then we could possibly suspect a leak. So what we do is we then pull up this checklist and run it, and when it gets down to here, it says if one inner tank depletes faster than the other by at least 300 kilograms in less than 30 minutes. Make sure I've got the right one here. Do not use. Let me find it. This may not be the one I'm looking for. Gravity fuel feeding. Ah, here we go. Here it's for gravity fuel feeding. And let me find and make sure. Quantities. So yeah, it's the gravity fuel feeding. It's basically if we lose a fuel pump, is what it is. I was looking at the wrong one. I did want to talk about that one though, but it was just based off of the flight plan. So anyway, this is why you bounce the numbers off the flight plan between that and the aircraft. But as far as the other thing I'm talking about is if you were to lose one of your fuel pumps, and the aircraft began gravity feeding. It says if you gravity fuel feeding, it's engine mode selector to ignition, avoid negative G, and then your max flight level for gravity feed is based off of this. So what you do is you look down here, and it says current flight level if time above 30,000 is greater than 30 minutes. So it's saying your max flight level is the current flight level if time above flight level 300 has been 30 minutes. Flight level 300 if flight time above 30,000 is less than 30. So what you'll, well, I don't know if you saw me do it or not, but when we pass flight level 300, I start this timer. And most operators, I can't say most operators do, but it's not part of our SOP, but we just do it as a reminder. It's something you need to check and set. So when we pass 30,000, I start this timer, and then once we've been up here for 30 minutes, then we just stop it. We freeze it, so it shows 30 minutes. And what that does then is that's our reminder that should we have to go into a gravity fuel feed situation, and I look down there and I see 30 minutes, I know we've been above. So our current flight level is our max gravity feeding ceiling. If I look down there and it's still counting up to 30, then flight level 300 is our max flight level. And the reason I think it just has to do with the actual fuel temperature inside the actual temperature of the fuel and its ability to gravity feed. I don't have much more information on that. I just know that we set it for this checklist. And of course it'll be the highest of flight level 150 or 7,000 feet above airport, takeoff airport, if flight level 300 was never exceeded. And if you're using Jet B, then it's 10. So you'd actually have to descend in that case. But yeah, when reaching gravity feeding ceiling, then fuel cross feed to off. So right now you're cross feeding because that's positive pressure from the pump to the engine. But once you get down below, or you get to your max ceiling, because we don't want to burn all the fuel from one tank, right? So if we go here and look at our fuel page, alright, and gotta hope he's got this thing set up. If not, we're going to see an engine failure here. Well, it should be. I hope he's got the systems going here. So, and this would be a good example to show the procedure here. So let's do a fuel imbalance. Okay, so if you got a fuel imbalance, we'll check the fuel on board. And the reason you do that is you don't want to cross feed if there's a fuel leak. And there's a famous A330 that glided down to a landing because he did that. So we don't suspect a fuel leak. How would I know that? Well, this is the fuel burn from takeoff. And we had 7,000 on board at takeoff, so 7 minus 2 is 5. So I don't suspect a leak. So I can go ahead and do this. So the first step is cross feed to on. So I come up to the side here and I follow my systems up to the fuel panel, and then I come across to cross feed. And of course I want to look and see that the cross feed valve is open. It's normally closed, which you can see. So cross feed to open, and then the next step is on the lighter side and in the center tank, fuel pumps off. So we're just going to cross feed a little bit. So this is the lighter side and the center tanks. We're going to go those fuel pumps off. So left tanks and center pump off. Okay, and that's associated. Okay, notice it says engine mode selector ignition. When tank left fuel required, tank left feed gravity only. Now, we're still under positive pressure though, because we have fuel being pumped from, well, this center pump should show off, so it does not. I need to squawk that. That center pump should be off. Well, they both should be off because there's no fuel in the center tank. So, but anyway, so that's going to pump under positive pressure over to that side. But we're taking the fuel, most of the fuel, and we're transferring over. Look at how full this tank is getting. So let's go ahead and really cross feed now and get it back in balance. But the point here, and it's cross feeding much faster than what it really would. The point is with this procedure is you don't want to continually get into a situation where you're cross feeding from one tank, or you're going to get way out of balance, right? So this is why it gives you time with that procedure of gravity feeding, and it says in here when reaching gravity feed ceiling. So we need to get down to the gravity feed ceiling, so then you know, we can stop cross-feeding, so on and so forth. Because once you lose those pumps, you're going to be gravity feeding, right? So if you lose those pumps, you're going to be gravity feeding. So what you're going to want to do is, instead of gravity feeding above your ceiling, you would turn on the crossfeed and then use positive pressure from the good pumps while you descend down to your gravity feed ceiling, and then you could turn the crossfeed off, and then you'd still be gravity feeding, but you'd be down at a safe altitude where you can do so. So that's the whole point. I know that's a long story, but I thought I'd talk about it since we're not doing anything else up here. That's a long story as to why you'll see the operators press that cron and start the time. So I know now that when this gets to 30 and I freeze it, okay, at 30, there we go, that my current flight level is now the max flight level. So if I'm up at 38, then boom, I don't have to descend down. I don't have to cross feed at all. However, if I've been up, about 30 and above for less than 30 minutes, then let's say I'm up to 35 and I'm at 25 minutes, and then we have those pumps go out. Well, I got to descend down to 30,000 with the cross feed open and cross feeding from the good pumps until I get down to that level, and then I can turn the cross feed off, or as I showed you earlier, I'm going to get into a fuel imbalance situation. Yeah, so anyway, that's why the guys, the operators, will start that time when they pass 30,000. Let's put that up here. No. Yeah, I do. It's kind of backwards, but okay. Yeah, see, I got all these 38,000s in here. That's it's not required. I think that might be something with the AIRAC or whatever when it pulls it in. But so you see the checklist here, and I'll bring you over here to the actual airplane. You can see what I was talking about. So what we got here is, we'll look at the fuel page. All right, and you can see that when I come up here along the side and get to fuel, here, come across. See, when I press the cross feed, the valve opens. It's normally closed. And since this is the lighter side, I want to pump fuel from the right so it burns here and doesn't burn here. So on the lighter side, you open those pumps. That should go amber as well. And once it burns down, which it is, then you shut those, or you turn those pumps back on and then open the cross feed, and now you should be balanced again. So that's the whole point. But what they're saying is, if let's say these pumps failed, right? So now you're gravity feeding, but you look down and you see, man, we haven't been, whoops, I need to cross feed here. Now we're truly gravity feeding. If I haven't been above 30 for more than 30 minutes, I've got to go down to 30,000. So we would have to cross feed, as we're doing now. And actually we want to do it on the lower side. This thing cross feeds so fast that I don't have time to talk. So we want to burn from the side that has positive pressure to the engine and descend down to 30,000. Once we get down there, we can stop cross-feeding, because if we stay in this configuration for too long, we'll burn all the fuel out of one side. So that's kind of what I was talking about before. Nothing in the SOP says to do that, but if you don't start the time, then you have to assume that you're under it and be more conservative and go down to 30, so which means you're going to be burning more gas on top of you know, the situation that you already have. So yeah, so that was a little bit about the gravity fuel feeding. Let's see, what else can I show you in here? Let's take a look. If you ever have to, which you may set up failures, if you ever have to go back to the airport after you take off, and of course these aren't available to you, unfortunately, but if you ever have to go back, which we do sometimes, we have to decide, are we going to burn the extra gas to get down below max landing weight, or are we going to land overweight? If the situation is serious enough, we'll just land overweight. It is a limitation, but you can land overweight provided that you do this procedure here, and no maintenance action will be required. So first of all, we look and see use config full for landing unless specified by airborne procedure or limited by landing performance. So max weight is 1,000 kilogram for landing in config full. It's max weight by ton for landing in config full. Go around in config 3 with a climb gradient of 2.1%, so that's all important. Okay, so the airport elevation, let's say we were taking off at sea level, and the outside air temperature was, let's say ISA plus 10, so 25. 73, that's the max landing weight for config full. If aircraft weight is above the maximum weight for landing in full, then you use flaps 3. So if we were over, if aircraft weight is above the maximum weight for landing in config full, you'd use flaps 3 for landing. So if we were above 73, then it's flaps 3. And you want to do your landing distance check, which there's a procedure to do that. For approach, pack 1 plus 2 off, or turn the APU on and supply the packs with the APU. Speed at runway threshold, VLS minimize, vertical speed at touchdown. So you're going to want to slow all the way to VLS and then minimize your vertical speed at touchdown. It says at main landing gear touchdown, max reverse. After nose wheel touchdown, apply brakes as necessary. Brakes fans on immediately. So that is the procedure for the max landing weight. And then what you have to do is they'll look at what you write down. You're going to want to note your touchdown, your vertical speed at touchdown, so that you know, they could determine, you know, what type of maintenance action has to be applied based on that weight. So, all right, and that was over here. Sorry. I keep forgetting that I don't have, man, I keep forgetting that I need to switch this. I need to pay more attention to that. So this checklist that I was running while you were sitting there in the blind is right here. And of course you won't have access to this, but just kind of for some knowledge for you that if you do have to land overweight, you look at the airport elevation, you go down to the outside temperature at landing, and that's your max landing weight config full. It says if your aircraft weight is above that weight, you do just landing 3. And then, of course, you follow these procedures. So that's really all I wanted to talk about, those two things there for now. We'll do more on the next one. But I need to go ahead and start looking at getting set up for the approach. So let's hide that. And let's go ahead and go to London City. And let's look at our arrival. Okay, so now we're approaching Hanley. I'm going to review this chart first, and then I will take you over to the airplane in a second.
So I guess we could probably. No, it's not going to work. So we'll just do it. So first thing we do is we come in over Hanley, and we're going to need to cross Rogby between right at flight level 200. So if we go over here and we look at Rogby, it's got constraint 38, so I don't know. All right, so let's brief this real quick. London City, UK, it's plate 40-2 Delta, 27 October 17, effective 9 November. It's an RNAV star, it's a Jacko 1 hotel. It's for runways 9 and 27, max speed 250 below 10,000. Note it's an RNAV 5. Requirement is RNAV capability or VOR DME, 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 or GNSS, which we have all of those. I just want to make sure I don't get behind here. Okay. Standard routes may be varied by ATC. Aircraft may be instructed to a waypoint following radar vectoring and report non-RNAV1 status on first contact with Thames Director. So we're going to cross Rogby at 200, then it's Timex, Advad, Rotmu, Nudna, max 250 below at Nudna, Inlim, max 250 at 12, and Jacko, max flight level 210, flight level 90, max is 210 knots. And the transition level is assigned by ATC, and it's in hectopascals. We're going to use 9 as transition level, just to keep it simple. For descent planning, pilots should plan for possible descent clearance as follows: 20,000 by Rogby, 12 by Inlim. So we're going to build these in, and they're in there already. 9 by Jacko. Actual descent clearance will be as directed by ATC. MinSafe in the London City area. Shit, I forgot my, well that's good, I didn't, I was doing a bunch of talking anyway, so. I didn't want to hear that in the background anyway. So the MinSafe in the area is 2300 in this quadrant here, and 2100 here. For the approach, it's London, UK, ILS DME runway 27. It's for CATS A, B, and C aircraft. It's a small airport, excuse me. Plate is 41-2, 29 January 16, effective 4 February. The ILS localizer is India Lima Sierra Romeo. Why is he still talking? Shut up. Okay. And let's go back to the right display. The ILS frequency is 111.5. 274 is the inbound. 1220 at glide slope intercept, or correction. It's going to be 1220 at 2 DME right here. We'll pick up the ILS at 3000. ILS minimums will be set for category C, 630. Missed approach climb gradient's 2.5, that's 611 above. It says BAE 146 aircraft can have a DA of 540, and these are the minimums. So we'll still be category C, a little bit, quite a bit faster, so 630 with 2,400 meters. And so that's the minimums. Airport and runway is 19 feet. We talked about the MSA already. If we have to go around, just climb straight ahead to 2 at 5 DME off ILSR, turn right. To the compass locator, and then at 2000 or as directed, and then be a parallel entry with right turns inbound 274. And this is the holding procedure right here. And then you can come right out of the hold to the final approach fix if you need to. Only for aircraft certified to carry out approaches at 5.5 degrees. So we're going to be cheating a little bit here. Let's see, where's the 1 at? Let's make sure. I just have to find the 1, and hopefully this doesn't apply to everybody. That's the localizer descent angle. Okay. So, yeah. Let me look at this. I haven't flown this one. Straight in landing. I think this is not the one we want. I hope I haven't flown us into an airport that's going to have a 5 point... that's just for 1. ILS, so I think what we're going to have to do is we're going to have to do the... this still says 5.5 degrees. I don't like that. Let me look and see. Missed approach. Oh, I know what this airport is. I know exactly what this airport is. There's actually a BA-46 crashing into it. So that's the localizer descent angle. It says ILS glide slope or localizer descent angle. So this is going to be one of those steep approaches. So we don't have a steep approach kit, but we're going to make it work. So I wanted to come into London City because it looked really cool on the map. So we're going to do it. So we'll get fully configured and nice and slow. And what I may do to help out is get the boards out in flaps 3 and to help the descent, but we'll see, because this is a steep descent. Whenever I planned this, I didn't look at this. I did it pretty quickly, but I didn't look at the descent angle, so it should be pretty steep. And I'm going to actually look in the... I'm going to go ahead and start down as well. I'm not going to make this first crossing, but we will go ahead and start a descent managed. There we go. That's open descent, but nothing I can do about that. So we'll pick this up here and we'll descend at 5.5 degrees. I know exactly what approach this is. In fact, I might show the video when it's over with. I believe we got some steep obstacles or whatever in the area. It says for aircraft certified to carry out approaches at 5.5. For ILS minimums based on a MITS approach, climb rate of 2.5. That's for 1. And for 2, it looks like that's the localizer glide slope out, so it would be a CDFA. Yeah, but it looks like still the glide... See, normally you... Well, our limitations where I work the CDFA, you couldn't do a CDFA with a localizer descent angle of 5.5. That's really steep. So we're going to try to make it work out anyway. And let's see, we're on the descent now. And what else? That's localizer glide slope out. We got Pappy's high ALS approach. We're going to use low braking and its visual conditions. So all of that for the approach. Now I have to put in the performance data here. X-Enviro, weather briefing. Let's see, EG. It's not going to let me. That's annoying. There we go. EGLC. Okay, I'm going to have to tune in the ATIS 3635. See if it'll pick it up. Nothing. Alright, so I'm going to use it off of my, either that or I'll just pull it up real quick. EGLC METAR. London City winds are... 080 at 9. See, now the winds have shifted, so this is going to be a bit of a pain. Let me see. Let me see what runway 9 is, because it looks like we're going to have to do the ILS to 9 now, as opposed to, because I can't get this. So the ILS to 9, still the 5.5. So let's go ahead and put that in. Seems
London City information.
there we go.
Echo.
Perfect.
1500 Zulu weather. Wind 330 at 5.
That's fine.
Visibility more than 10.
3305.
Sky clear. Temperature 18. Dew point -21. Altimeter 3021. Arriving runway to 7.
Perfect.
Departing runway to 7. Advise on initial contact. You have Echo.
Okay, so that's going to work. Getting a little bit behind. It seems whenever I do these briefings and talk about all this stuff, I always get myself behind. I'm going to have to start like 20 minutes out from here on out. All right, let's go to 12. And we just need 36 miles to get there. And that's 12 by Inland, so we don't need the boards anymore. Alright, so let me go ahead and let's get this box set up and let you take a look at it. Okay, so landing performance. It's, what did she say? 3021. So that's going to help. So that's 1023. 1023. Temperature was 18 and 3305. Oh man, this approach is going to be brutal. 3305. You can tell I threw this together fast. All right, the ILS 27 is going to be 5, and we're looking for, what's note 2? Missed approach is 3.5. And let's see. 630, which is 611. Above the ground. Config full. We're going to be nice and slow. The flight plan. We are going to fly straight to let's see what we got here. Plan mode. Yeah, I don't want to do that. I got to put in some I don't like the fact that it's let's put it in there and see what it does. Okay, not Alkin. Race. These are probably, let me see. Let's see what kind of radar minimums are, nav arrivals. I just got to find something here that gives me a fix. I don't have any chart that does, so I'm just going to have to wing it here. ILS 27 via Lavig. Jacko, Godlu, let's take a look. There's the arc. So, nope, That's not the one. That's a hole. I think I'm just going to wing it here. I'm going to intercept the localizer at, because I just don't have time now. I'm running out of time to, it's already 11 o'clock, so we're just going to intercept at, let's find the min safe here. Yeah, we're just going to intercept at 3,000. So we're going to come off of here on a heading, as if ATC was vectoring us. And then, yeah, there we go. Okay, so we need to go ahead and start getting prepared for this. All these briefings, man, are just getting me so behind because I'm trying to explain everything. And all right, Jacko. So Jacko to this point is 50 miles. I don't know why they want us to be all the way down at 12 by inland, but I think I'm going to do a shortcut here. Yes. Let's go ahead and go down to 3. Open descent. And to save me some time, as soon as we get past Nudna here, and these altitudes they got here are not for terrain; they're for traffic, in and out of the airport, crossing over, stuff like that. So we don't have any traffic. So we're going to go after Nudna, and we're going to extend off the runway. So I'm going to put a discontinuity here after Nudna, just one I'm familiar with. Insert. Let's clear it. Ugh. Alright, and then I'm going to extend off of Lavno. So we'll delete this. Delete this. Now we'll extend off of the runway there. And the barrow is going to be 1023. Okay. And set her down. Alright, so now we've got it set up. It's going to be a steep approach, so we're going to get configured really early. And in fact, once I get visual, I'm going to see what's down there, and I may just convert to a visual approach. That way I won't have to stick with the ILS restrictions. And I can just fly it visually to the airport, which is nice. And 41 times 3 is 12. We're at 8. Yeah, we can actually stop at 5. No rush. So let's go ahead and pick a heading here to the right. Sorry, I'm trying to shorten this up a little bit. I'm just short on time. So there's the heading. Coming down through 10. And we'll go ahead and set QNH. The approach plate here. One thing I didn't really discuss yet, because just haven't had time, is where we're going to taxi off the runway at, which is going to be at the very end. We're going to use auto brakes low. And as I said, exit at the very end. Okay, perfect. We can go on down to 3. In this area that we're in, the min safe altitude. Can't see it, but I'm trying to look for it here. Probably gonna have to go to low. Yeah, the reason they've got you taken out so high is because there's London Stansted, which is right here. This is why they take you all the way out around, and probably, oh, I know why they keep you high. It's this airport right here. You have to descend. I thought New York was congested. You have to descend steeply, so we may be stuck with it here. So we'll see. We'll see how it works out. Never been in there and didn't honestly, to be honest with you, study it too much. So, all right, we need to go ahead and start getting slowed down here. Okay, confirm the approach phase, and let's see. I tell you what, when you're sitting in front of the computer, this stuff is just, you got tunnel vision for one, and you just feel like you're in a box. It's just very, not confusing, but it feels like you got 50 people standing around you. So we're going to go direct, what is this, fix? Lavno. Direct Lavno, and the radial in is going to be the inverse. Again, having to use my mouse instead of just pulling up a plate on my iPad is annoying. I need to get these charts on my iPad. So 274. 94 is the radial in. Boom. Insert. Pull heading. All right. Let's take it on down to 3. Alright, quick briefing. Briefing's confirmed. ECAM status check. Seatbelts are on. Barrel ref is 31023 set. Minimum is 611 set, and engine mode select is normal. That checklist is done. And let's bring all of this up so it's right where I want it. Shouldn't need that anymore. And I'm getting nice and slow early because it's going to be a really steep approach. Let's see how well it's modeled. Right there's the airport, I believe. And we'll be picking this up. It says that that's the VOR. We're going to nav it up originally, but 24 miles out off of London. We're really far out right now. So I am going to angle it in and cut the distance a little bit more.
Okay, I'm back, and like I said, I haven't been in here before, and really something like this, you've never been into an airport, you really just sit down like the night before you actually go, and you go over, and especially this you know, for your company, anybody going into London City, this would be briefed when you first get into the company. They would tell you about these, you know, airports with these crazy approaches and stuff. But if for some reason we can't get down because we're unstable, then the plan, rather than going to the alternate, is what I'm going to do is I'm just going to go over to what is this, South End. It's where we're, it's what we're overflying right now. I think it's Manchester. So the plan will just be to go to Manchester and land, which is why we should be, I mean, if we were online or if we were actually flying for real, you wouldn't be doing this because you're flying right over their airspace. That's why the arrival takes you around it. So anyway, since I'm pushing 11 o'clock, 11:30, we're just going to kind of shorten things up here and just make it work. Up in here, I believe, is our airport. So let's come back over here. Flaps 1. Kind of wanting to take in the sights too here. I want to see what all is out here. I suspect this would be a pretty great approach to fly if we were actually flying out here over the water like I was originally planning on. Just a little bit more now. Normally you wouldn't configure this early, but just want to make sure with this steep approach that I'm going to see if boards will help me stay on speed better than the flaps full. Probably not, but once I go flaps full, the speed brakes will retract. So alright, let's go ahead and arm the approach. Whoops. Why are we not arming? Oh, maybe, okay, hold on a second. What the hell's going on here? 11.5. Well, let's make sure. What the hell? This is not good. That shouldn't make a difference. It should still arm. Now that's not right. Okay, AP1 plus 2, out glide slope, local blue. And now we were well within inside the usability of the glide slope, but it's still arm. Or the usability of the localizer. That's usually out at 18 miles, but maybe it's shorter in this one because it's so close to Manchester. Could possibly be. Alright, there's London City. And I'm not going to mess with these later because I don't want to take my eyes off, so I'm just going to put them on now. There's the loc. Oh yeah. The speed now. Loc. So 5 miles out, we'll be picking up the glide slope and descending down. And that's where I'm going to be fully configured before we even start down on the slope, because if it is truly 5 degrees, which it is, it's almost double. At 5 miles out, we should be 1,500, and we're going to be 3,000. And that's all because of, I guess, Manchester right below us. What a place to put an airport. Yeehaw. Alright, something's fucking going on here, so. Alright, so what we're going to do is climb straight ahead to 2, and at 5 DME turn right to the LCTR at 2, and that's where the hold will be. So if for some reason we can't get stabilized, we're going to do the published mist, and I probably should do something here. Change the, it's probably not going to let me. Yeah, we'll just leave it there. I don't think you can change it in this one. And that airport looks weird. Okay, flaps 2. Down. Flaps 3. This is gonna be a fucking nightmare. Okay, flaps full. I don't have the use of the speed brakes now. This thing is going to be super unstable, so I plan on a go around here. We're way up there. I could just do this visually since there's really no... okay, there's the slope. So I'm going to set 2,000 for the mist, and this is going to be an exciting approach. If we do go mist, we'll just go to Manchester. Because we're probably not going to be able to hold this and be stable, but we'll see. Probably, since we don't have the steep descent kit, we're probably going to be getting some glide slope warnings. Not glide slope, but sink rate. We'll see. Look how steep that is. Yeah, we're probably going to be getting some sink rates and maybe even a pull up, but
2,500.
we can not worry about that. We'll just brief it. Looks like it's doing okay, but honestly, I don't think the modeling of this is quite right. If we were descending at 2,200 feet a minute, or what is it, 1,500, you'd be seeing an increase in airspeed, big time.
2,000.
This is 5.5 degrees descent path. I can't remember if I've got mine set up or not. So let's see if it's yeah, it's set good. Okay, manual control, autopilot's off. I thought it was going to be, yeah, see, it's starting to speed up a little bit, but I think it would be, I mean, a lot, you'd be going a lot faster than this. Granted, I did configure early, but still, yeah, there it's starting to speed up. I'm going to
1,000.
cheat a little bit here. Man, I'm getting some pretty shitty frame rates here, so I can't promise anything on the landing.
Minimum.
Continue. This ought to be fun. Not only is it a steep friggin' approach, it's a short runway.
400.
And I'm going to be right on the brakes right away.
300.
That's the descent rate. What is this freezing?
200.
There's the pull up.
Pull up.
100.
Pull up. Pull.
50. 40. 30. 20. 10. 5.
Okay, I don't know what happened to my frame rates, but they were pretty much shit. And very low. Maybe it just, I'm in a busier area and my graphics settings are too high, but I was like, we're slowing way down there. Alright, we'll make a left here. And then before I can't get the reversers to come off. Jesus, I got to get a better setup with my joystick. And look, the frame rates are still killing me. What the hell? There we go. Yeah, these frame rates are brutal. I mean, that's what I was fighting against on the landing. It was like I was pulling and the nose wasn't coming up, and it was because of the frame rates. Of course, the brakes are hot. I mashed on them. Anyway, before I... yeah, look at this. What the hell, man? What the hell is going on? Was harder than hell to do with those with this pausing and stuff in the frames. Man, that was brutal. All right, let's see. Where are we gonna park at? Let's go down here to the left. Clean all this up while we're taxiing. I'm not sure why they got the taxiway so far, so close to the grass. The FBO is behind me, but I don't like the room for parking there, so. Alright, so while we're moving, let's get everything situated. APU started. Brakes are hot, we can clear that. Yeah, we'll park down here. Brakes off. And weather radar and predictive wind shear. I don't know what that, of course I've never been that close to the ground descending at 2,000, 2,500 feet a minute, so, but yeah, we obviously got the pull up, but again, this I've never done. I've never basically been trained on a steep approach or with a steep approach kit, so that's all new to me. But yeah, that's one of the reasons why you know, you'd be briefed on the approach, and you'd also you know, I guess we can pull straight in here. Why not? I was going to pull sideways, but we'll pull straight in so we can use the better pushback the next time. And since I'm going to be a long transient stop, it's going to be a long one. We'll take it over here to the very end. But as part of this video, I'm going to at the end, I'm just going to show real quick the aircraft that crashed going into London City. It's a crazy airport. I didn't realize this was the airport. Again, here we are with the damn pauses. What the hell? Alright, normally, jeez, these pauses are killing me. Ugh. I don't understand what's causing it. There's maybe I do have my stuff turned up too high. We'll see. Alright, so that was the approach into London City, which I didn't prepare for like I should have, and ended up being at 5.5 degrees. Okay, APU bleeds on, and shut them down. Let's call for ground power. Boy, that's just a bit too loud. I'm sorry. Ground services, get some ground power out here. Let's get some low pressure air. And connect that. We can shut the APU off. So I am running out of time. So I am just going to quickly put everything where it needs to be. Flaps are 0, park and brakes on, it should be chalked. Alright, so I'm going to save here. So that was fun going into London City, but I have to admit I didn't do my homework like I should have. I just kind of put this flight together last minute just because I had a little bit extra time, but yeah. So let's see, this is a round world flight. Leg 7. And we're at EGLC, London City. Parking. Save it. And now what I want to do here real quick is seen this video before, but I know nobody's watching right now, but for those that maybe watch it later, YouTube, okay, EGLC crash. Yes, I didn't put 2 and 2 together. I didn't put 2 and 2 together whenever I first watched this, or I first thought about coming to London City. But then when I actually seen the steep gradient, it just made sense. So yeah, here we go. Let me move this guy over here, and then we can enlarge this and go to the left display. So, so here's London City. This is where we just landed without a steep approach kit. And you can see it's a tight, tight little airport. And like I said, I didn't do my homework. So here we go. I wouldn't call that a hard landing. I would call that a crash. They probably had injured people in there. That was the fact that that airport, that aircraft is still in one piece. Now that right there, I believe that's. I don't think that's his boards. Maybe that's part of their steep procedure, is the ability to have the speed brakes up. But usually you've got some sort of a steep approach kit. I'm not sure on the Airbus. I haven't flown it with that on it. But anyhow, he should be well into the flare by now, and he's not. And man, this is. I cannot believe this is not a crash. But what got me on the flare was. The jittering, the stutters, and I've got a pressure stick, so you know I'm pulling because it's not flaring, and that's because the stutters and the frame rate. So we're lucky I didn't crash. Look at this, boom! That is that's incredible. That should have been a crash. If I would have touched down in the Airbus that fast, like that with that steep of a descent rate, it'd be a crash. The gear would be smashed up into the wheel wells and the just a total airframe. This is, I would be interested to see. This is just a straight up crash, and I just can't believe that. But anyway, that's the approach I just did. And if you look at that again, just imagine you're a passenger. And I mean, people probably were injured on that flight. Yeah, that's incredible. So I want to look at the next one. Here is another airplane coming in from the cockpit view. Let's just get right to the meat and potatoes here. Boy, I wish your simulator could give you this picture, man. It just doesn't do it any justice, man. You've really just got to be there. Look how steep. I think also the reason it's so steep is because I see buildings in the approach path as well.
500.
See, I don't think they're going to have any bells and
Minimums.
whistles going off because their procedures got
100.
them turning off that stuff.
50, 40, 30, 20, 10.
Nice. Much better than the other one, huh? Alright, anyway, I just wanted to show you those. That's because that's where we basically landed. So, anyway. Alright. If you watch this at a later date, it was interesting because, like I said, I hadn't done my homework and looked up the airport before I went. I just had a couple hours to fly and just looked up an airport that was pretty interesting to fly into, and boom, this came up, and I went and ended up, when I looked at the approach, it was a 5.5 degree descent rate, which I think requires a steep approach kit or special procedures for sure, which I've never done, so we don't have those approaches. But anyhow, that's it, and thanks for watching. See ya.